Please help me to welcome Mr. Jonathon Nortier, Principal Mine Engineer at AMC. John has over 19 years experience in the planning, evaluation and operation of open pit mines. He has managed and has been lead mining engineer for several technical reviews, feasibility studies and strategic optimization studies across a range of commodities and locations. He's also a highly competent user in multiple mine planning software packages and is experienced in mine planning, optimization and operating cash flow evaluations. Please welcome Jonathon. Jonathon.
So I thought it'd be a really good opportunity to share just a couple of case studies we've worked on over the last few years. I'm not doing the geometallurgical one because I struggle to pronounce it. I'll use something I'm a bit more familiar with. But we've got the first one on emissions reduction. All right, so yes, g'day. I'm from AMC and we use a number of the Datamine suite, but MindMax is something we use a lot in the strategic space. So we'll cover off on a few of those today. So GHG emissions or greenhouse gas emissions, it's not something I always get that excited about, but this case study, we've sort of been able to sort of work it into the MindMax framework and processes and sort of have a look at how it sort of bends and stretches and manipulates the schedules. I'm going to step out here. So the purpose, want to sort of have a look at the impact of greenhouse gas emissions on a project's economics, on the schedule and how it impacts things. There's obviously a growing expectation from the community, from investors and employees.
Sorry, John. Can you to use this mic or you walk around?
All right. Is that better?
Yeah.
All right, thanks. Typically, GHG sort of done at the back end of all the planning, but there's a way to bring it into the mine planning, an opportunity we see it. So how can we bring these emissions and potential costs into the schedule and model it in our strategic mine planning? All right, so it all starts with the inputs. So a lot of the greenhouse gas emissions coming from your mobile fleet. So you need to start looking at estimating what how many kilos of carbon dioxide you're going to be producing. So for loading, sort of go to the first principles approach or use some benchmarking. If you've got data from site, great. Haulage, start looking at your haulage modelling. And looking at sort of, source destination, you can start looking at diesel burn and calculating your CO2 emissions from that. Drill and blast ancillary, again, benchmarking or first principles on that front. So these are, I'm not an expert in greenhouse gas emissions or the frameworks, but anything on site is generally going to be called your scope 1. And then scope 2 is sort of energy, emissions from energy sources generated off-site. And scope 3, I won't go there. But it's mainly focused on 1 and 2. All right, so that's your mobile plant for processing. Scope 1, if you're generating that power on site, typically from diesel or gas, or solar battery, and you can apply some conversion factors going to vary to different generator efficiencies. Scope 2, if you're getting your power from the grid, you need to sort of look at your local jurisdiction and what those emissions are likely to be. So there's lots of data out there. For Australia, you can have a look at where you're getting your power from. That data is readily available. Or even globally, you can get some averages. So again, on inputs, if it's a high level scoping, sort of use generic sort of cost inputs or CO2 conversion factors. And as you build up the level of your study, you're going to have to start getting some better estimates on those inputs, no different to costs or productivity assumptions like any other study. All right, emissions targets. So look, the target's going to vary by jurisdiction and company. and how what your targets are going forward. For this example, we've got a sort of a diminishing target constraint that we'll apply based on sort of a baseline that was sort of set around 2024. You're not going to apply necessarily this constraint all the time, but this sort of triggers potential carbon credit purchases. So you need to sort of understand what are your targets, what are your goals, what are you working towards, and then, like everything else in MindMax, you can add it in as a constraint and start planning around that. All right, so in this particular case study, and well, case A and case B, we've got a magnetite deposit producing con only. Pellets and direct reduction iron are excluded from the emissions. Conventional diesel drive load and haul, this is scope 1. Grid supplied electricity with some assumptions around how much power you need to process that material. And looking at the on-site GHG emissions only, ballpark 20-year mine life. All right, so here we have sort of the process flow in MindMax. Fairly typical. So you got your mining at the top, splitting it into ore and waste. Over on the left here, got a sort of typical waste dump modelling sort of structure where you can sort of embed it into your landform construction, work out your truck hours, and as an additional process, so another downstream process from your truck hour process, you can calculate your greenhouse gas emissions all the way through to that dumping location. For the up the top there, we've got ancillary and drill and blast. Again, you're going to have some conversion factors for those. So they're getting calculated. You've got your excavators, we're already calculating the hours for those with processes. So another downstream process for those for their greenhouse gas emissions. And then all the specific ore streams. So you've got to sort of match the processes to what you're trying to model anyway. So it's just an additional downstream process. Then you bring it all together in a calculated field. And so now you've got your total greenhouse gas emissions from your mobile fleet. For the plant, in this case, it's a scope 2. Energy is being supplied from the grid. All right, so this is sort of the general process. So we're calculating essentially the mobile fleet scope 1 emissions. We can then go, let's run an unconstrained, how much CO2 are we producing? We can then constrain it and understand what happens to the schedule. We can then go, all right, let's say we want to exceed it, but we need to purchase some carbon credits to basically allow us to exceed that. So 3 options we'll have a look at. So yeah, this is, I like to use dark mode. I really like that feature in MindMax, so thanks for that. A bit easier on the eyes. So yeah, you've got your constraints that you applied to S1 greenhouse gas emissions, and for the second scenario we do, we've got a hard constraint, so can't exceed that. So what's that going to do to the schedule? And before we get there, and the other, so this here, what we're seeing here, we're in the capital expenditure tab, and basically carbon credits increase or decrease in price. It's the forecast. And so here we're saying, all right, in 2025, if we want to exceed that process, we need to buy a certain amount of carbon credits to increase it. So the schedule is going to go, if I want to make that decision, I've got to buy some carbon credits. So the tool was already there, so we just able to apply that logic to it. All right, some results. So total movement, so we've got the 3 different cases here. So the non-constrained, the declining baseline, and the carbon price. So quickly you'll see essentially just 2 schedules. So the unconstrained and the carbon price pretty much follow the same total movement, and the declining baseline really impacts the schedule quite a lot there. And we see this quite a lot with no constraint versus carbon price. Generally, the cost is there, but the scheduler generally wants to buy those carbon credits to achieve an optimal solution. So on the scope 1 emissions, it's very similar to the total movements because it's tied to the mobile fleet. So we sort of see the baseline really restricting those scope 1 emissions, the unconstrained being the green. And then we start to see the effects of these carbon credits coming into play. Certainly later in the mine life, you've got longer hauls, and it's impacting what the schedule is doing. As you would expect, you've got to pay for that extra tonne of carbon dioxide, and the scheduler is changing what it's doing to reduce those emissions. All right, and the cash. So, sorry about this chart. The axes don't quite line up, which is one of my personal bugbears. But we can see here the unconstrained and the carbon sort of follow a similar profile, but where we're having to buy carbon, it's sort of it's running slightly lower to the unconstrained case, and we get that delta in the cumulative cash. And the baseline really is a lot lower, and we're sort of sitting in the negatives. So just to simplify that, before I get to that table, sorry. This here is the financial outputs tab in the reports, and just thought I'd show the amount of carbon credits, the cost of those over the life. So we've got all the individual capital targets, capital expenditures being triggered, and that's the cost each year for those carbon credits for that particular scenario. So it's triggering those as we go. So in this example, that cost of about $10 million to hit that essentially original schedule. Okay, so so in summary, no constraints, DCF 42 million, add the constraints, negative 142, with carbon credits down around 8. So we're seeing adding emissions consideration can significantly affect the project value. Adding the baseline leads to a negative DCF after 14 years, and incorporating carbon credits. You get a similar operating profile, but it costs more to hit that profile. Probably an interesting observation, and more of a proof of concept that if you want to start bringing this into your strategic planning and understanding the cost and the impact and how you might schedule, then the tools are there. All right, and then on the second one, so similar scenario, but we're going to look at putting a power plant on site. So quite common for a remote operation. You need to start having a look at what power system you're going to be using. So for this one, we sort of set up 4 different capital options with coal, gas, diesel, solar, battery, and use, again, the capital expenditure and timing to optimise for each. Integrating this with the scope 1 and 2 emissions. All right, so on the process map, so pretty much everything on the left is very similar, but what we're adding in here is an extra split, and adding in the different capital options for power, and incorporating with that is the operating costs. So you get the capital expenditure and the timing of when that's going to hit, and then how much it's going to cost per tonne of processing to hit those targets, and we can have a look at the outcomes. We did, and you can run this as a whole, so you can ask MyMax to choose which is the best option. But often clients want to see each option, so you can sort of run it for each and just understand what the impacts might be. It's a bit of an easier story to tell. All right, so again, we've got the capital expenditure chart tab, and you sort of in the different power source and capital, and tie that to the process you want to trigger. Okay, so on the total movement, so we've got the 4 different options here. So what we've changed is the power plant and the capital and the operating cost. Got total movement over the time over the life, and we can see that just with those changes, we're starting to see some different total movement profiles between the different options there. On the scope 1, so we can report all this out. We can see the different emissions from the operation. And if we add the scope 2 in, because for some of them we have some external power coming in, you can sort of see the split. So external power is the greens, they're getting a grid supplied. Coal is sitting up the top here. Gas in the middle, diesel, and then solar battery down here. So this includes the load and haul plus the emissions for generating power. You can start to sort of understand what the emissions are going to look like for each different option. And then also tie that in with so you can evaluate the economic basis, so we can have a look at the different cumulative cash flow for each. So here, solar plant looks good, then followed by gas and similar for grid and coal. You can also then, as well as that metric, have a look at the other metrics you might have, with this one being total peak emissions. So you can get an understanding of, with that decision, what are your emissions and any scope 2 emissions as well. So again, with the other case, it all comes down to the inputs that you're using and your confidence in that, choosing the different options. But I suppose the purpose of what I wanted to talk today was just that if you want to incorporate emissions into your mine planning, the tools are there. It's just how you apply them. But it's really what's on those inputs that are key to getting useful information out. So in conclusion, your GHG emission estimation, you can't see that slide. Is that it? Yes. Consistently incorporated into strategic planning as a leading indicator, so you're not waiting till someone processes that data afterwards. You can use it as a constraint to understand what's going to happen. Inclusion of emissions into your planning is likely to have a material impact. So if it's going to come in, you really should be understanding what impact that's going to have on your operation and maybe what your strategic decisions are around that. And as I said a couple of times, inputs are critical. So really want some to be confident on those inputs for the level of study that you're looking at. Just as a sidebar, this is some excerpts I've stolen from another paper that's going to be at an underground conference shortly. So I couldn't present this one today, but just thought I'd give you a couple of little things. So this is for a underground open pit underground transition, something that we do a lot of, and we use MindMax as typically the tool to evaluate that through a few different methods. But typically we'll have a look at a couple of different options, so open pit only, transitioning at different RLs, or underground only, and we'll sort of understand the economic outcomes of all those decisions. But in the ESG environment, we can start to add different metrics to that assessment. Maybe we're not just looking at NPV, we want to look at other stuff. And basically we have that tool there with MindMax. We can add in the extra processes to sort of gather a bit more of a better understanding early on of what impacts this operation might be having. So we just talked before about greenhouse gas emissions. So you can evaluate the different options you're looking at just on tonnes of CO2 emitted. You can have a look at tonnes of CO2 per ounce of gold if you want to sort of benchmark your operations across that. Or another interesting one is NPV per tonne of carbon dioxide. So the data's there that you can manipulate the processes in MindMax, and you can start to optimise, maybe not just on NPV, you can start to have a look at some different metrics. So yeah, tools are there. So that's just a couple of slides from that particular paper, which will be coming out shortly. All right, it's enough on emissions. We'll move to the next one. So this is this was a case. I'll jump to the next slide. So the situation is quite a long life mine. It's been in operations for a long time. Typically been mine planning is around NPV, which is pretty much most places. The strategy was in NPV, about 8 years left in the mine life. Yeah, got to hold it close to my face. The board basically wanted to have a look at, well, what options do we have to increase the mine life, to help support the community that's been built around this mine, and they're not so focused on NPV, they're looking for consistent cash flow and a longer mine life. And the stakeholders here aren't just interested in NPV, they want jobs, the governments want taxes, so they're sort of looking at it slightly differently. But to do this, there's significant capital. They've got to replace a lot of plant, replace a lot of the truck fleets, build new waste dumps, tailings dams, the list goes on. Mountainous area, minimal storage for just run-of-mine ore, and pretty much no storage for strategic stockpiles. So you can't store stuff and bring it back in later, which is sort of a typical mine planning tool. And marginal low-grade material, so because of that, just if it can't be processed, it's got to be wasted. So if you've got to hit your cash flow targets, you might just have to process more high grade over these few months and waste the low grade, which shortens the mine life. So there's a few things to balance in this particular case. So modelling considerations. So variable throughputs are very different types of ore coming into the plant. So the throughputs are all embedded in the block model as far as the mining rock preparation. A lot of AMD considerations, which we manage by controlling the net acid potential. So that's all embedded in the block model. We're using MineMax to make sure that the waste dumps are sort of staying within a certain constraint. So like you might have for the mill, keep the gold grade above a certain thing, or keep the deleterious elements sort of sweet in an iron ore operation. We're doing the same on the waste dumps to manage that NAP. Geotech considerations for the foundation, so a certain proportion of the waste dumps need to be a certain rock quality. Integrated haulage modelling, so we'll develop the haulage model for the pit, apply that to the block model, and then have a haulage model for the waste dumps, apply that to the waste model. MineMax brings the two together so you can optimise your haulage, and variable cut-off grade using a net smelter return. Okay, so on the throughput, it's probably one of the easier parts of this operation to get right. So, bring in throughput through the block model, use your maximum mill operating hours to constrain your schedule. And this is the output. So all the different stages and how much ore is coming through from those. So you can see that variable throughput over the years, but we're sort of managing the how many processing hours per year. All right, so on the haulage costs, so haulage two ways. So the operating costs are generated from the fuel burn and the hours that are embedded in the model. So we've generated the costs from that, not just on a dollar per tonne. We've also got an ageing fleet that needs replacing. So we've got our sort of current fleet hours as a constraint. If we want more hours from the haulage fleet, we need to buy new trucks. So that's a capital trigger. And so what we can see here in the blue is the existing fleet, slowly declining in hours, and the new fleet. So every red bar there is a new truck that's been purchased. That all gets incorporated into the capital requirements. You never just run one MineMax scenario. There's always lots of different options the client wants to use, and once it's set up, this is where its real power is. So this is just a handful, but you want to look at different waste dumping options, different truck options, different all sorts of options. For this particular case, you run your options and you can understand what impact that's going to have on your haulage fleet, purchasing new trucks, getting them to site, etc. All right, cash flow. So because the mine was sort of set up in NPV territory, there was a lot of ore available at hand. So the trick for this project was to cap the cash at the beginning and not throw away low grade so you could extend your mine life. So the hardest thing for me was stopping these sort of bars at the front here from just going through the roof and then having sort of this no cash for the next sort of 5-6 years. The other thing that it needed to do was pay off all this capital. So the blue line at the bottom is the capital schedule for the first, for the life of mine. You can see that it's very capital intensive for the first 4 or 5 years. So we needed to balance that. So the schedule is looking at how much it's got to purchase, but we also want to have that free cash at the end of the day for the shareholders and the community. So it can balance that. So this was the final outcome. I'll just talk through a bit of the process, how to get there. So as you might know, Mine-Max is a nice feature where you can apply financial constraints, mins and maxes, and it works very well. So we have here the red line is the maximum, so we're trying to cap the cash and push it out to the future, and had a few gaps here initially, which were quite sort of trying minimum and trying to force it to solve that problem, and wouldn't because the ore wasn't available, or we've had certain physical constraints, so we're not mining cutbacks too quickly. But what I found with these constraints in such a complex model, it just takes so long. I'm very impatient. There was a few nights there, bottle feeding my daughter, just sort of updating the Mine-Max model just to get another run going overnight, just to try and to find another solution. So once you get this sort of first run done, I found it then really useful to have a look at some of the other reports and metrics you've got to play with. So this is not my Bitcoin trading account. This is looking at the NSR grade, so the net smelter return. So basically $1 per tonne of what we're sending the plant. And this was sort of the rough trend over the life of mine. I found this a much more effective method for faster processing was to just flex this, just to try and massage the cash flow to get something that's sort of more palatable for the client. The other limits as well, you need to make sure you've got a very clean capital expenditure, because it'll go, oh, you've got this thing that you're not using, but I need to reduce the cash flow, so I'm just going to buy this $15 million expenditure to pull it in. So I found you can, once you turn the financial constraints off, using something like this will just help sort of take some of that noise out of it, and it'll process a lot quicker. This was the other thing, the other tool for this particular one. So as I mentioned before, we're trying to extend the mine life, which meant not throwing away too much low-grade or marginal material. So Mine-Max is choosing what to process and what to waste. So applying some limits on the low-grade and marginal material at different times in the mine life, just to help it make that decision, just to try and help its hand. So initially just had some minimum, maximum values of how much you can waste of low grade and marginal, changing that times just to help it sort of make those decisions. Because Mine-Max, its inherent behaviour is to maximise value, so it's going to try and get the maximum value at any point in time. With these sort of restricted cash flow cases, you do need to sort of treat it a little bit differently just to get it to sort of do what you need it to do. All right, and then on the net asset production potential, so just some examples of that it's managing the waste dump NAP values. So these are the 4 different waste dumps, and where it's got to sort of stabilise at 150 to get the units. And the other values is sort of bringing in some better geotechnical material that was also very low in NAPP. But this, I suppose I showed this, you're looking at looking at grade, you're looking at throughput, you're looking at haulage, you're looking at cash, you're looking at capital. You also got the environmental constraints in there. It's sort of bringing it all together to give you some solutions and not just one.
All right, so yeah, in summary, the setup could manage multiple inputs, constraints, and deliver numerous scenarios for the evaluation. Ultimately show there was a compelling option for an extended mine life with a consistent cash flow while meeting all constraints. And it's just a great example of what we really like to use MindMax for, just to some of these complex operations, bringing in all the constraints from all the different departments, pulling them into one, and generating mine plans and seeing what comes out the back end. So yeah, that's all my content. Open for questions.
Thanks very much.